Today we are going to discuss about problem solving through C programming. So let us start with the problem solving. Now let us take some examples on operators, on arrays, if conditions and all, and let us see some problems on how to predict the output. So to predict the output, let us start with the first problem. Now in the first problem, suppose we have two character arrays. So character S1 of, for example, the size is 100, comma. There is another character array of size 50. Now, what we want to do? We want to read two strings into this character array. So, we have to write %s twice to read two strings and into the arrays S1 and S2. So, what we are going to do? So, we will write as %d here, okay, comma, we will write a scanf statement inside the printf. So we'll write scanf, we want to read two strings, so we'll write %s twice followed by s1 comma s2. Now, so here our problem is to read two strings. So the scanf statement is used to read strings from the standard input device, and how many strings we have read, that is the written value of scanf, and the written value of scanf is printed by the printf. So let us first save and run the program. Now, so let us first save the program and compile and run. Now, look at here. So, in the standard input, it is waiting for the inputs to be given. Suppose I am giving my input as IARE as the first string and then college as the second string. So, the scanf is reading these two strings and stores into the character arrays S1 and S2. So, the scanf returns that how many strings it has read. So, the written value of scanf is given to the printf. So printf prints 2 as the scanf's written value is 2. So printf has printed 2. So you can see the output on the screen that the two strings you have given as input and the written value of scanf is printed by the printf statement. Okay. So let us move on to the next problem. So the next problem is, let us take some variables and let us write some arithmetic expressions and see what is the output of those arithmetic expressions. So let us take integer. There are three variables are there. Suppose I is equal to 2, comma, j is equal to 3, comma, k is equal to 4. Okay. Now let us write some arithmetic expression. For example, I is equal to I plus j plus k. That means the variables I, j and k are added together and the new value will be the addition of these three variables values are again stored into I only. Okay. Now similarly, j is equal to I plus k and similarly k is equal to I plus j. So here the original values of the variables I, j, k we are updating through our expressions. Now print the value of I, j and k. So let us write in the printer that we want to print the value of I, j, k. So I, j, k. Now, so for this program, the original values of I, j, k are initially 2, 3 and 4 and we have written some mathematical expressions involving only the arithmetic operator plus. So, the new values are getting updated into those same variables I, j, k. So, let us run this and see what is the output. Now, you can see the output. The I value is nothing but I plus j plus k. So, 2 plus 3 plus 4 which is 9. Then the second one is 13 and the third one is 22. So the updated value of I, J, K are now 9, 13 and 22. So this is a simple example of the operations involved in arithmetic expression and how to update the value of the variables. Now let us move on to the third problem. Now in the third problem, suppose we have initially x is equal to 10, comma, y is equal to 20, comma, z is equal to 5. Okay, and there is a variable I. So we have three variables x, y, z and I. Initially x, y, z are having initial values 10, 20 and 5. And for example, if I am writing I is equal to x less than y less than z, then what will be the value of I? So we can write %d, comma, print the value of I. So in this example, in what order the expression x less than y less than z will be evaluated? So if you see this expression, the relational operator less than is there and the associativity of relational operator is from left to right. So from left to right, at a time, all the three variables cannot be evaluated. So only two variables x less than y will be evaluated first and the result of x less than y will be evaluated with z. So x less than y, what is the value of x? The value of x is 10. The value of y is 20. So 10 is less than 20? Yes, it is true. So true means x less than y, the relational operators always returns true or false. True means returns 1. So x less than y returns 1. So 1 is less than z will be evaluated. So what is the value of z is 5. So 1 is less than 5? Yes, it is again true. So the final output of this expression is 1 which is stored into I and the output of I will be printed as 1. So let us run and check it. So you can see the output on the screen as 1, the value of or the output of I. So this way the relational expressions are evaluated from left to right. Okay. So let us move on to the next problem. Now in the next problem, let us write one printf statement and print. Suppose I am taking the index as 1 of a string 1, 2, 3, 4. Okay. Now plus let us take 2 of 1, 2, 3, 4 which is a string plus 3 of the string 1, 2, 3, 4. Okay. So the question is very simple. So 1, 2, 3, 4 is a string which is stored into array and index. The index numbers are given 1 of 1, 2, 3, 4, 2 of 1, 2, 3, 4 and 3 of 1, 2, 3, 4. So here 1, 2 and 3 are the index numbers. Like in array you know that A of I is same as I of A. So here it is written in the format of I of A. So where I is the index number. So here the index number is 1. So in index number is 1, 2 and 3. So for the string 1, 2, 3, 4 we have to check. So in the first example at index number 1, so the character 2 is there. Okay. So the digit 2 is there. So 2 means you have to check for its ASCII value. So 2 means the ASCII value is 50. Okay. Because 48 is nothing but 0, 49 is 1, 50 means it is 2. Okay. So at index number 1, the character 2 is there whose equivalent ASCII value is 50. Okay. So the first one you will get the answer in decimal it is 50. Second one at index 2 of the string 1, 2, 3, 4 at index 2 we have the character 3. So character 3's equivalent integer value is 51. Okay. And at index number 3, the third one, at index number 3, we have 4. Okay. We have 4. So 4's equivalent, 4 is a character there. 4's equivalent value we have is 52. So here the answer will be 50 plus 51 plus 52. So we can write like this here, 50 plus 51 plus 52. So which is nothing but in total it should be 153. Okay. So let us run this and check it. So you can see the output on the screen as 153, which are nothing but the equivalent ASCII values of the index values of the characters. So its equivalent integer values are added and then displayed. Okay. So hope this question is understood. Now let us move on to the next question. Now in the next question we are going to discuss about regarding a string only. Okay. So let us discuss about, let us take a string. So character, your S of 100. So S of 100 is a string. Now suppose I want to read this string. So I have to write scanf percentile S. So instead of writing percentile S, I am writing suppose percentile 4S. Okay. And I am writing the name of the array as S. And I want to print that string. So I am writing only percentile S here, comma, your S. So I am reading a string and just displaying it. Now in this small example, let me first take in the scanf, both are percentile S only, in the scanf and printf. So what will happen? So here I am just simply reading a string and display it on the screen. Okay. Now first run it and check. Now it is waiting for me to enter a string. So let me enter a string called college. Okay. Now you can see here the string college, whatever I have given, is simply displayed. So it is just a simple example of reading a string and displaying it. Let us make some modifications over here. Let me write in the scanf 4S. So 4 is nothing but the width. So how much space you are allocating for this string? That is, you are allocating a width of 4. Now this same program, if you run it, then what will be the output? Now let us see the output. So I am giving my input as the same input I am giving college. So which is nothing but 7 characters. So, but in this scanf, I have written only 4S. That means the width I have allocated to store this string is only 4 spaces. So, you can see the output as it has only stored up to 4 characters and it has displayed. So, the complete string has not been stored. So, be careful while writing the width specifier in the scanf statement. Okay. Now, let us go for a small variation. Now, in the next example, what we are going to do, in the next example, let us take a string S of 100 is equal to college. And let's take one more string S2 of size 50 is equal to, let's take a string IARE. Okay. Now, in the printf, I want to print both these strings. So percentile S space percentile S. I want to print S1 comma S2. So let us see what will be the output. Now let us observe the output. Can you see over here? So both these strings are displayed as it is college space IARE. Now let us do some variations to the printf statement over here. Now in the printf statement, suppose I am giving 10S. And here I am giving 10S. Okay. In both the cases I am giving 10S. 10 space I am giving. Now let us run it and say, check the output. Now whenever you will see the output, then you can find here the length of this string, the first string college is only 7 characters. So 3 spaces at the beginning you have got it. And IARE is only 4 characters. So before IARE, 6 spaces are there. So that you need to observe. Okay. Now, again, so if you are giving a positive width, so how much space you have allocated? You have allocated 10 spaces. Out of that, your string occupies only 7 characters if it is college. So the remaining 3 are the blank spaces you are getting at the beginning. Similarly, for the second string, the IARE is only 4 characters. So, the remaining 6 spaces you are getting in the beginning. Now, let us change this to negative. So, you can change the width to negative also. So, minus 10 and here minus 10 is. So, now let us see the output if the width is minus 10. Now you can observe over here, if the width is minus 10, then first the string will be printed. First the string will be printed and then the remaining, the string is containing 7 characters, remaining 3 spaces are printed afterwards. Similarly, the string IARE is printed, remaining 6 spaces are there at the end. So this observation you should do it, that what will be happening whenever you are writing positive width and what will be happening if you are writing negative width. Okay. Now instead of giving, suppose let me write here a 0 in the beginning, 0, 10s and 0, 10s. So I am giving the width of 10, 10 and I am giving a leading 0 here. So if you are giving a leading 0 over here, then what will be the output? Let us observe. So if you will observe the output, can you see over here that the college takes only 7 characters, remaining because your total allocated space is 10 characters. So the remaining 3 spaces are filled with zeros. Similarly, in the string IARE takes only 4 characters, remaining 6 characters are filled with zeros. So this facility is also there, that the spaces that you are not able to observe, if you want to fill it with zeros, then you can exactly observe that what are the spaces and how much the string takes and what are the remaining spaces. So here the remaining spaces I have just filled it with a leading 0. So this way also the width, how it is storing the string in the required width will be understood, whether it is from left to right or right to left, and with the leading spaces you can be converted into zeros. So hope this example will be clear to you. Now next we will go for one more problem. Now let us go for another problem. Now let us write the printf statement and understand the behavior of printf statement. Okay, so I am writing here %d and inside that there is one more printf statement. So again %d and inside that there is one more printf statement which prints a number, let us say 1, 2, 3, 4. So you can write number of printf statements one within the other. This is called nesting. So what is the nature of printf statement? So which printf statement will be executed first? So whenever you are writing one within another printf statement, the innermost printf statement will be executed first. So if you will see the innermost printf statement, so printf 1, 2, 3, 4. 1, 2, 3, 4 is a number which will be printed as it is on the string, as it is on the standard input. Now, what the printf statement returns, the innermost printf statement returns what is the length of the number it has printed. So, the length of the number is 4. Its length is 4. That 4 is given as the return value of the innermost printf. So, there is one more outer printf, the middle printf will print 4 because that is the return value it has received from the innermost printf. And then it has printed only a single digit 4 whose length is only 1. So that return value it will give it to the outer printf. So what is the output? Let us observe it. So let us run it and see. So you can see over here 1, 2, 3, 4, then 4 and 1. So all are combined together. So let us give proper spacing. Now if you will give proper spacing over here, then there will be, you can observe the output properly. So you can see over here, there is a change in the output. There is a change in the output. Why there is a change in the output? The innermost printf has printed 1, 2, 3, 4. No doubt. So it has given the return value, but there is a space also. Okay. So after percentile D, I have given a space over here. After percentile D, I have given a space. So that space is also counted as a character. So total width has become 5. Okay. Now in the second printf statement, along with 5, there is a space. So it will print 5 no doubt, which is the return value of innermost printf. It will print 5, but that is a single one and there is a space again. So it has given 2. The return value of the middle printf is 2. So it has printed 2. Okay. So whenever you give space, be careful. Okay. For example, I am giving over here. Instead of giving here, I can give tab. Okay, /t. I want to give a tab. That tab is also considered as a character. It is a valid character. So if you will check the output also, you will find that the innermost printf statement has printed the value 1, 2, 3, 4, and whenever it is returning, there is a, due to that tab is also counted as a character. So the total is 5. So that 5 is printed by the middle printf. Okay. That middle printf is also having, it has printed only a single digit, but along with that there is a tab. So it is counted as 2 characters. So the outer printf has printed 2. Okay. So be careful that what you are writing and whether you are giving any extra space or not. Similarly, instead of giving a /t, if I am giving some 5s over here, so or percentile 5d I am giving. So I am removing this. Now observe the output. After making these changes, can you observe the output? The innermost printf has printed the value 1, 2, 3, 4 and it has exactly the length of the string or the value 1, 2, 3, 4 is 4. So the middle printf has printed 4, but it has percentile 5d. 5 spaces are there. So that is 1 character extra. So it has that 5 spaces is counted as the 5 characters. So the output of the outermost is 5. So be careful what you are writing. Okay. So hope this question is understood and the printf statements can be printed one within the another in the form of nested. Okay. Let us move on to next question. Now in this next question, let us take one global variable. Initially int a is equal to 10. Okay. Now inside this, if the value of a is equal to 20 and there is a semicolon after that and printf high is there. Okay. Then there is a printf. Let us write here h1. Let us write here w1. And there is one more printf statement. Printf if a not equals to 20 and after that there is a semicolon and there is a printf statement which prints h2 and there is a outer printf statement which prints w2. Okay. So this is the question. Now there is a global variable initially containing a is equal to 10 and this global variable can be accessed by any function in C language. So that global variable's value 10, here it is compared with 20 and there is a semicolon after that. What is the meaning of semicolon? That do nothing. The meaning of the semicolon here is it is a null statement or do nothing over here. So anyway, if a is equal to 20, it is doing nothing. But here in this case, our a value is 10. So 10 is equal to 20. No, it's false. Okay. So this printf statement is not inside the if condition. So it will print first h1. Then when it comes out, then after that it will print W1, H1, W1. Now in the next one, if A not equals to 20, what is the value of A? 10. 10 not equals to 20 is true. But again there is a null statement, which means do nothing. So it won't do anything and it will come to the next printer. So it will print H2 and then it will print W2. So the output of this program will be H1, W1, H2, W2. So hope this thing is clear, that how you write what is the effect of semicolon, you can understand over here. Now let us see the output. So if you will see the output, you can see the output H1, W1, H2 and W2. Okay. Now let us remove this semicolon. One semicolon I have removed in the next condition. So in the first condition, A is equal to 20, there is a semicolon. That means if A is equal to 20, this condition is true, then do nothing. So here the A value is 10. 10 is equal to 20? No. So it is not doing anything. So the condition is false. So it is not doing anything. So H1, W1 will be printed as it is. Now coming to the next condition. If A not equals to 20, if it is true, 10 is not equals to 20. It's true. If it is true, then what is printed? H2 and W2 as usual at the end. Now let us run and see the output. You can see over here, you will get the same output H1, W1, H2 and W2. So if you remove the semicolon over here, it is not making any difference. Now let us keep the semicolon as it is there in the previous place and let us remove the semicolon from the first one. Okay, and let us run it and check it once again. Now you can see the H1 didn't come. So W1, H2, W2 will be the output. Why? Let us check. The value of A is equal to 20. So 10 is equal to 20? No. So if this condition fails, then printf H1 will not be printed over here. So it is considering this printf statement inside the if condition. So if that condition is true, then it will print H1. So here in this case, the condition has become false. So it has not printed. So it has started printing from W1. So be careful and observe where you are putting this semicolon. Okay. So this is about the small if condition to predict the output, and let us move on to the next question. Now let us take int A is equal to 9. Initially, there is a global variable A is equal to 9 and write A minus 3 semicolon, then A is equal to A by 2. Okay. Now next write if A equal to 3, you compare the value of A, then your printf OK. Put a semicolon and then else you print not OK. Okay. Now this is a very simple question. What is the value of A? A is a global variable. The initial value of A is equal to 9. Okay. Now A minus 3 you are doing. So 9 minus 3, but you are not storing it into any variable. Okay. So 9 minus 3 is going on, but the value of A minus 3 is not stored into any variable. So that's the reason the original value of A will be still 9 only. It won't be changed. Now the next statement is A is equal to A by 2. So 9 by 2. 9 by 2. 9 is an integer. 2 is an integer. Integer by integer is also an integer. So 9 by 2 is 4. Now A value is now updated. A is equal to A by 2. So A by 2's new value will be stored into A. So now A is equal to 4. So if A is equal to 3, then you have to print OK. Otherwise, it will come to the else part and print not OK. Let us run and see the output that it is not OK. Okay. Now, so let us do the variation over here. Suppose if I am writing A is equal to A minus 3, then what will happen? A is equal to A minus 3 whenever you will do, the value of A gets updated. So 9 minus 3 initial value of A was 9. 9 minus 3 is 6. So A value is updated to 6. So here A is equal to 6. Now that 6 is now 6 by 2 is done, which is equal to 3 over here. 6 by 2 is done, which is equal to 3. So A is now again updated to 3. Now you check if A is equal to 3, then print OK. So you are comparing 3 is equal to 3. Yes, it is true. So now the output will be OK. Earlier we got the output as not OK. So you can see the output on the screen. It is OK. Now let us go for next question. Now let us understand another question related to loops. Now let us remove this global variable. Now int x is equal to 1. X is a local variable. Initially it is 1. Let us write a for loop. You know that for loop has got 3 parts: initialization, condition checking, and revaluation, or you are updating the value of the variable. So here I don't have any initialization as I have initialized outside. So let me put a semicolon. And in the condition checking I am writing x less than 5 is the condition, and then x plus 1 is the statement for updating the value of the variable x, and then I want to print the value of x. So let us write %d, x. Now what will be the output of this program? Now you can understand over here the initialization has done outside. So x is equal to 1. 1 is less than 5. Yes, it is true. Condition is true. So when condition is true, for loop, the control goes inside. So inside we are printing the value of x as 1. Okay. Now you can see whenever it is coming for updating the value of x, x becomes x plus 1, but it is not stored into x again. So x value will not be changed. So when x value is not changed, you will get the output as infinite loop. So infinite times 1 is coming on the screen. So again I'll show the output. So now your loop has become infinite. So as the value of x is not updated properly, so the x value always remains 1 only. So 1 is less than 5, the condition is always true. So as the condition is always true, so it is continuously printing 1 on the standard output device. So be careful regarding this kind of statement. So this leads to infinite loop. So be careful about the infinite loops. Now let us go for another example. Suppose initially x is equal to 1, comma. Let us take another variable. S is equal to 0. Now let us write a for loop. So for no initialization, as we have done it outside, then x less than 5, and then the same thing will just change x plus is equal to 1. So whenever you do x plus is equal to 1, then the loop will not be infinite. So inside the for loop, we will do s is equal to, or s plus is equal to x. And this printf is outside the for loop, and we are printing the value of s. So here what is happening in this program? Initially x is equal to 1. So 1 is less than 5. Yes, it is true. Then go inside the loop. So s is equal to s plus x. S is the initial value of s is 0. 0 plus x becomes 1. Then x value is updated to 2. 2 is less than 5. Yes. Then s is again s plus x. So this process will be continued till x becomes 5. So when x becomes 5, 5 is less than 5 is false. So it will come out of the loop and it will print the value of s. So let us run it and see it. So you can see the output is 10. So it is 1 plus 2 plus 3 plus 4. So it is 10. Now, let us do a small change to this program and put a semicolon over here. So if you will put a semicolon over here, then what is the output? Now, let us run it and check it. So if you will put a semicolon over there, you are getting the output as 5. So why the sum value is only 5? Why not 10? So you need to understand the program over here. So whenever you have put the semicolon, it means that the semicolon is inside the for loop and it means do nothing. So here initially x is equal to 1. Okay, 1 is less than 5 is true. So whenever it is going inside the loop, it is not doing anything because of the semicolon. So it is same as writing the semicolon here. So whether you put the semicolon at the end of for loop or right inside, both means the same. Okay, so it is not doing anything. It is just updating and checking the condition. So the loop will run, no doubt it will run 5 times. When x becomes 5, the loop condition is false and it is coming out. So whenever it is coming out, the sum is equal to s is equal to s plus x is executing. So initial value of s was 0. So 0 plus x value is 5. Whenever it comes out of the loop, the variable x has been incremented 5 times. So the value of the variable x is 5. So 0 plus 5 becomes 5 and it is displaying the value of s as 5, not 10. So you can see the output once more. So be careful where you are putting the semicolon. Okay. Now let us move on to the next problem. Now in the next problem, let us write down is small while loop, while 5. I am simply writing printf IARE. Now what will be the output? Now if you will look at this, that while loop is always true. This while loop is always true. So it will print the string IARE continuously on the screen. So please check the output. The IARE string is continuously printed on the string. So it has become also an infinite loop. So this question also goes into infinite mode. So be careful while writing the code. Now let us move on to the next problem. So hope this problem is clear. Let us move on to the next problem. And in the next problem, let us write one preprocessor directive type question. Now we will write hash if, hash and if we will write if x is equal to 3, then we will write inside hash define y as 3. Hash else we will write down hash define y as 5. So here we have written hash if, hash else and hash end if. So these are the preprocessor directives we have written. So if x is equal to 3, then we are defining that y should be 3. If x is not defined, x is not equals to 3, then we are defining y as 5. Okay. Now inside the program, we are printing the value of y. So what value of y will be displayed as output? So in this small program, we can see here, we have not initialized the value of x. So what x contains? X contains either 0 or garbage. It depends on the compiler. So obviously that if condition will not be true. If x is equal to 3, you are comparing the value of x with 3. So obviously it is false. So it will come to the else part and it will define the value of y as 5. So y value is 5 and inside the main we are printing the value of y. So 5 should be our output. Let us check it. So you can see the output on the screen as 5. So this is about the conditional directive, the program. Now, so we have discussed a number of problems related to hash if, hash else preprocessor directives and your arrays and loops today. So we will discuss some more problems in the next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.